Today on Coding 101, we are checking out classes, specifically abstract classes and interfaces.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Coding 101 is provided by CacheFly at CacheFly.com.
This episode of Coding 101 is brought to you by Hover.com. Hover is the best way to buy and manage domain names. It's simple, honest, and easy to use. For 10% off your first purchase, go to Hover.com and enter the promo code C1018. Welcome to Coding 101. It's the Twitch show where we introduce you into the wonderful world of the Code Monkey. I'm Father Robert Balacer.
And I'm Shannon Morse. And for the next 30 minutes, we are going to get you all learned it up and everything you need to know to be a C# code warrior.
And I have had way too much sugar.
I have too. See?
Yeah. Now, last week, Shannon, we covered classes, which was nice because we're doing a little something different with this module where we revisited the first language that we taught. And we're giving sort of a 102 rundown. So it's not just loops and variables, but we're talking about some of the more high-level concepts. And of course, we have to cover classes, because if we're covering objects, we need classes.
But it's scary. Actually,
it is a little
not
scary.
Too bad.
Yeah.
I started playing with my own code, and I was like, okay, I could do this. So you want to start off with some snubs compiled?
Let's do that, please.
Yeah. All right, let's go over to my desktop. So I have Visual Studio Express running over on my desktop here. Ta-da! And I've created this one called program.cs. If you're confused about how to get a console program running in Visual Studio Express for Windows Desktop, the free version, just go to our last episode. We ran through it in there. Lou did a great job of that. So I made this one. I'll go over here. Okay, so I made a new class called food. Ta-da! See? Class called food. And under it, I decided to make this public string called color. So under color, I also chose that color is generally going to be green for pretty much every food out there. Except under there, I also decided to make a variable class.
You've got an inheritance.
Class,
I like that.
yes.
That's important.
So I made an inheritance of food called vegetable. And under vegetable, I decided to make all vegetables orange. So then I went over to program, and this is totally weird, but hey, it's an idea. So under here, I have class program, and under static void main string, so I didn't change any of that. I made my first food, I just called it food1, and that one's going to be green. The second one, now the reason I put this in here, you'll notice a mistake, but I put this in here specifically to show you that just because I wrote purple in here, it's still gonna say green when I run it because I haven't overridden the original green up here.
Which is important. Lou told this about us.
Exactly.
Told us about this the other day, which is if you're going to inherit from a class, if you're going to make a derivative object, then you need to override if you're going to be changing from the original.
So you'll notice when I run this, it's not going to say green, purple, orange. It's going to say in the console write out, it'll say green, green, orange. Down at the bottom, the third one I wrote out is vegetable pumpkin. So I made pumpkin, which is a vegetable, which is in the class of food. And under here, I just changed pumpkin's color to orange. Now when I run this, I'll hit start up here. You'll notice that it says green, green, orange. Ta-da!
Ta-da!
Yeah, so another very simple one. It's very similar to the one he did for animal last week, but it gives you an idea of something else that you can do with it. So you don't have to use ints all the time. You can use strings too.
Woohoo!
Yay!
Now this is actually a very good example because we've been trying to tell our audience that this is not earth-shaking. I mean, if you watch the first module of Coding 101, if you watch Lou teach us C#, it's the same concepts. The only thing that we're doing is we're organizing them better. We've always had this idea of making things easier to use, be them functions or methods, so that we don't have to rewrite them over and over. This is just taking it to the next logical step and letting us create objects.
Yay! Now, I also wanted to take a moment and send a shout out over to our viewers who have joined our community over at Google+, which is bit.ly/twitcoding101. We had 4 specifically that I wanted to point out this week. First up was Cosmic Ray. He linked us to a lot of really good videos made over at channel9.msdn.com, which are fundamentals of C#, and they work in Visual Studio Express as well. So they're really, really good videos, and the guy's really nice to listen to as well. So I enjoyed them. We also got one from Nathan Fulmer. He went on a mini rant, but it was a good rant.
It was a good rant. It was a very good rant.
Basically, what he got down to was just because you know the syntax of a code doesn't mean that you're a programmer. You need to know how to solve problems. So he links to a couple of different places where you can find some problems that you can try to figure out with code, as well as some more information about it. A really good article. So definitely check out his links in there on the Google Plus community as well. The third one I wanted to check out was Kelvin. So Kelvin said, hey, don't forget Mono, which is available on Mac. So that is a C# compiler on Mac. And the last one I wanted to mention was from Joe. So Joe shared this information about C# in particular. He said you don't have to necessarily use a compiler like Visual Studio Express.
Right.
You can do it in Notepad, and he links us to a bunch of information about how to do it, and he walks you through it. He's also really good about helping people if you run into any mistakes, if you want to run it in Notepad. So thank you guys so much for sharing your expertise in C#. Really appreciate it.
Those are all great tips, especially I liked what Nathan was saying. And this is actually something we said at the very beginning of Coding 101, which is the reason why we're switching languages, we're not sticking with one for any amount of time, is because we're not really teaching languages, we're teaching methodology.
Yes.
We're teaching problem solving. The whole idea is, can you take something in the real world and solve it inside of code? And that's dead on. The other thing I really like is the fact that Joe gave us the information about being able to write in Notepad. And of course you can do that because code is code. But the reason why we're using Visual C# is because A, it's free. You can get it from Microsoft. It doesn't cost a thing. It is a big download. But what you get with that download, and this is especially important for beginners, is you get a developer environment that tells you what you can do.
Yes.
Right. We've both used this.
Really handy.
Yeah,
It just gives you a nice little red squiggly every time you mess something
It'll
up.
tell you when you did something wrong, and it will also give you the options. You can always use those drop-down menus to say, I just used the console command. What else can I use? And it will tell you all your options. So yes, a Notepad, I like the idea of using Notepad because it's really for those people who know what they're doing. But if you're doing a complicated project or if you're just starting, at least learn a little bit in the IDE so that it helps you out.
Yay!
Yeah. Now, speaking of help you out, what if I wanted to help you get the word out about any projects that you might be running?
Ooh, how would I do that?
Well, as they say in real estate, it's all about location, location, location. On the internet, it's the same thing. Location, 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 although we could say URL, URL, URL.
This is why no one ever goes to my website.
Yeah, well, but if you've got a great idea, if you've got a great project, if you've got a great website, but you've got a horrible, horrible name,
Yeah.
it's difficult to navigate there. You
Nobody
don't
can
get the
find
drive-by traffic.
Snubsy123XQY.
You know, how
thought it was
about
good.
how about snubs.club?
Oh, that would work.
That's easier,
that's
it's
kinda
shorter, and you could do it with Hover. They're the sponsor of this episode of Coding 101. Now, what is Hover? Hover is the #1 trusted provider of domains. When you have a great idea and you want to secure a domain for it, you do want something that's catchy and you want someone to set it up for you who's trustworthy. Well, that's what Hover gives you exactly when you need it to get the job done. You'll find the perfect domain for your idea so you can get started working on it rather than all that back-end stuff. And right now, Hover is having a sale on all new domain extensions through September 1st. The sale is for new and existing customers alike. Summer is the perfect time to start a new project, and every single domain is deeply discounted, so you could choose what you like. .club, snubs.club, how about snubs.ninja, or
I like snubs.pub.
snubs.guru.
Ooh.
Or how about snubs.justaboutanything? That's what you get with Hover, anything you need. Now, people love Hover. Geeks, developers, designers, and programmers love Hover because they know that they'll have the best tools and support. But you don't have to be an expert to get a domain because the service is simple enough to use. They take all the hassle and friction out of registering a domain. Hover gives you easy to use, powerful tools to manage your domain so that anyone can do it. Now, I told you that it's easy. Let me explain how easy it is. All you have to do is search for a few keywords, and Hover will show you the best available options and suggestions. In fact, one of the things I like about Hover is sometimes when I'm searching for a domain and I can't get the one I like, it gives me suggestions that are not just close to the name, but it'll say, well, I think you're trying to do this. Here's an even better domain. That's one of the services that makes Hover so easy. They also offer a valet transfer service to make the process completely painless. For free, Hover will take care of the entire process for you and let you know when your domains are settled in your Hover account. They'll transfer all your DNS settings, no matter how many domain names you may have, and it's no additional cost. Now, the big thing, however, has to be that Hover is honest. They don't believe in heavy, up-handed selling. They're not going to sell you something and then immediately turn around and say, oh, but you know what? If you want full functionality, why not get this? Hover is known to be just honest. They'll sell you what you want, when you need it, for what you need. Plus, WHOIS privacy is included for free on every domain that supports it. Now, if you ever do need support, Hover has the best customer support around. It's known for its no wait, no hold, no transfer phone service. So when you call, a real person is ready to help. They also offer you volume discounts. They'll give you a discount on your domain renewal starting at just 10 domains and going up in value from there. The idea is the more domains you have in your account, the less that you have to pay to renew them. So here's what we want you to do. Visit Hover today to register your domain name and for 10% off your first purchase. Take advantage of their summer sale now. Go to hover.com and use our promo code C1018. We thank Hover for their support of Coding 101.
I'm ready.
Ready?
I'm ready to move on from them classes.
Well, we can't really do that yet, Missy, because, classes are going to be on our minds for a while. Why are we doing that?
No, no.
I really don't know. Okay.
Because it's fun.
It is fun. But let's move on to the Ivory Tower. Now, last week we learned about classes, and it was a lot of information, but hopefully people were able to sit down and say, oh, I get it. This is just sort of a way to organize everything, right?
Yeah.
Yeah, you got it, no problem. You were able to work it into your programs, and you could use all your existing code. If you did the first module, drop it into a class, you're good to go.
Yes.
Now, let's do a quick review. When we talk about classes, we talk about blueprints.
Right.
Right? We talked about this last week. A class doesn't actually exist. A class is just a blueprint for something that could exist.
Yes,
right?
I remember that.
And then when I initialize it, when I declare, when I create an object from that class, then it actually exists. Then I can actually interact with it.
Yeah, I
right?
understand that.
Yeah, and I can also I can instantiate multiple copies of that class.
Right.
Right?
Yeah.
Okay.
And you can name them just different names.
You can give them different names. You can give them. You can overwrite certain methods within various classes so that you can customize the classes. But the idea is, you write it once. It has a hierarchy. It has all the methods. It has all the variables. It has all the data that you might need. And then you just make as many copies as you require, and you change the things that you have to change.
Okay. So where do you go from here?
Well, we talked last week about declaring a class, and when we do, go ahead and go to my laptop really quickly. You may remember this. This is the code to declare my laptop. That's Snub's laptop.
Me.
There we go. This is the code to declare a public class called C101. So public class C101, and then inside of here is the body. The fields, the methods, the properties, the events, everything that you might want to include.
Pretty much anything.
Yeah, it could be the console commands. It could be your group of variables. It could be any of those methods/functions that you may have written in the first module. No problem, right? And then we also know that when I want to actually turn that into something, I have to instantiate it. I have to create the object. This was the bit that we learned last week that some people kind of freaked out about.
So this is where you actually create it.
Right, so I go from blueprint to something that actually exists inside of system memory. In this case, I have C101 object 1, so I know that object 1 is going to be something that I can reference based on the class called C101, and then I'm creating a new class from a new object from the class C101.
So every time you do this, you can create a different object, and they can all just call back to the same class and do the same thing.
Right, so C101 object 1 equals new C101. C101 object 2 equals new C101. And I can do that as many times as I need.
Yeah.
Right? Easy.
I get it.
Easy peasy. Now let's talk about a little something that we did at the end of the lesson last week, and that is the idea of inheritance. Lou briefly talked about this. You used it in your code.
Yes.
The idea is you don't just have to use the class the way that it's written.
Right.
Right.
You could override it.
You could override it, but in order for you to override it, you first have to inherit. So go back to my computer. Inheriting from a class looks like this. So I've got my class, public class module 4, but this right here tells the compiler that I will be inheriting from C101. I will now make a subclass module 4 based on C101. And then in here, I could use those override statements to, make sure that I'm using the proper methods, or
Right.
that they're spelled out correctly for whatever I'm going to be using it for.
So in my case, this new class or this subclass ended up being vegetable, and then I
Right.
could just override it with whatever
Correct,
information I
correct,
wanted.
correct. And this is all part of the grand scheme of C#, which is to give your data, to give your methods, to give your code better hierarchy, better
Yes.
organization. Yeah, come on back, Brian. So does that part much
It
make
makes
sense?
Yeah, it totally makes sense to me.
Yeah,
Takes a little bit. I think it really helps to do your own code to understand it.
it does.
That's how I did my own code, and I was like, oh, okay, I understand classes now.
Now there's a little wrinkle here.
Uh-oh.
Yeah.
Don't tell me that.
Yeah,
I just got it.
No. This is good. This is actually going to make it easier, because there are always going to be some people, when you write a class and then you inherit it and you start overwriting it, people are going to say, well, why would I write it in the first place if I'm just going to override all the
That's
methods
a good
that I have
point.
in
Why
there?
would you?
Well, it still does make for better programming. It still does make for better hierarchy. But there are two other tools within C#, actually within most object-oriented programming languages, that allows me to create something that is like a class, but not quite.
What?
Yeah. Let's talk about the first one. It's called an abstract class.
Okay.
Okay, so imagine this. If a class is a blueprint, so the blueprint that's ready to give to system memory and say, go ahead and make an
Yes.
object out of this.
Got that part.
An abstract class is more like the architectural outline. It has the shape, it has the general look and feel, but I can't actually create it. System memory wouldn't know what to do with it because it's incomplete. It's what we call...
So it's kind of like somebody drew a picture and they were like, here, make a blueprint out of this.
Yeah, they can't be classes can be instantiated.
Okay.
Abstract classes cannot.
Oh, okay, I got it.
Okay.
Kind
So
of.
they're incomplete. They're incomplete.
Why
So-
would you make something incomplete?
This is exactly what we want to talk about. Why would you make an abstract class? Why would you
Sounds
make
like a
something
waste
that's
of
incomplete?
time.
It sounds like a waste of time, but it's not, for this reason. Even though it can't be instantiated, I can still create a subclass of that abstract class.
You can?
I can, just like I did with a regular class. And then I can overwrite the components that are incomplete, and I can fully implement them.
Oh.
Right. So think of it this way.
Depending on whatever your needs might be.
Yes, exactly. Depending on what my needs might be. But the reason why I'll use an abstract class is if, let's say, on a programming team, I want to force other people to use a particular structure.
Oh, yeah, that's smart.
It's actually this is good programming.
Yeah.
So if let's say I'm the lead programmer for a project, I will create an abstract class that has all the methods that I want people to use, and it has all the variables in the way that I want people to use them. It has all the procedures spelled out in how I want people to write them. And now I tell all my programmers, I say, I want you to use this class, this abstract class, to create what you code.
Oh, that's awesome.
It's like,
It'll keep things organized
Yeah.
and hopefully not break.
it gives
So it's
them a
good for
structure.
teams.
It gives them a structure.
That's cool.
Yeah, and now creating an abstract class or declaring an abstract class is really no different than declaring a class. The only thing that's different is you add the word abstract before class.
Okay,
Right.
that's easy.
But that tells C#, tells C#, I cannot instantiate this. This is not complete. If you tried to compile an abstract class, it will not work.
Yeah, that
because
makes sense.
there's nothing in there, right?
It would probably just give you an error.
Yeah, well, and it will also tell you this is abstract, it's never been fully implemented. Now, a few things about abstract classes. One, they're created with the keyword abstract.
Okay.
Two, they are incomplete, therefore they cannot be instantiated. They cannot be created from the class. They can be created from a subclass of that class, a subclass that has fully implemented the procedures within it. Abstract classes are incomplete, therefore they can only be used as sort of what we call a base class. And non-abstract classes that are derived from abstract classes must complete any abstract members that are inherited from that abstract class.
Ah, okay. So this is where the coders come in.
This is where the coders come in. So if me, again, as the lead programmer, I make an abstract class and I have a bunch of abstract members, abstract methods, so on and so forth, the programmer that I tell to use my class can't just take it, turn it into a subclass and run it. He actually has to go through, see all the places where I've put abstract and put in the proper implementation.
He has to fill in the blanks.
He has to fill in the blanks.
Interesting.
Now, there is another bit of this called the interface, the interfaces. It's the same thing as an abstract class, except it's completely devoid. All it has is the taglines.
What?
Yeah. But they do the same thing. Again, the whole idea is to enforce a hierarchy of coding.
Okay.
Okay, and just as a class allows me to organize methods and variables and procedures, an abstract class lets me organize methods and variables and procedures, leaving some of them open to the programmer, and then an interface leaves everything open to the programmer except how the program is structured.
Okay. Again, this is one of those times when the code will make more sense when you see it.
Yeah. Now, I know that, exactly. So this is kind of complicated. Before we get way off the rails, before we get too confused, let's actually show you what it looks like in the IDE. This is the time when we bring in our code warrior. We welcome back to the show the man, the myth, the muck legend, Mr. Lou Maresca. Lou Maresca, thank you very much for joining us again here on Coding 101.
Hi.
Thanks for having me back.
It's always good to see you. Now, Lou, you showed us a little bit of inheritance yesterday, and it was funny because we did get a couple of people who wrote in and said, wait a minute. If you're just going to override like Lou did, then why do I write the class in the first place? I mean, if you're just going to get rid of everything I gave you, then what's the point? And that's why we're talking about abstract classes and interfaces.
That's right, yeah. I mean, the big thing about abstract classes is, a lot of times there's actually a lot of what we call design or coding patterns that are out on the web or around, what computer scientists use today, where they use the abstract capability, because what it allows you to do is, like you said, sometimes classes get so big and get so much implementation in them, you don't necessarily want to override everything, but you do want to follow what we call the signature or the architectural plans of that class still. And so that's where abstract kind of comes in.
Yeah.
There's another type, I don't know if you wanted to get into that yet, but we also call what we call an interface too. And that one's a little different from an abstract class, because what that is basically just, it's basically just like a signature or a breakdown, a blueprint of what you want the class to implement, but it doesn't have any code in it, no implementation whatsoever. Right. It's just a breakdown of it.
Yeah, interface has no body. There's nothing. There's just, okay, there should be this method, and this method.
Oh, okay.
We leave the rest up to you. But, Lou, it's interesting because when someone is coding individually, just by themselves, just practicing, I often hear, well, why do I have to do this? It's so much easier if I just write it. Why am I writing an entire class just to console a menu? It doesn't make sense to me. But I think the key is, when you start working with larger organizations and much bigger programs, you want to be able to understand someone else's code without having to pore over every line. And if you force them to use a class that everyone else is using, then you at least know what's supposed to be in each place.
Yeah, I mean, a good way to think about it too is it's just a building block to the bigger thing. So if you're building a small piece of functionality, classes are what they call separation of concerns, or you're supposed to basically separate the functionality from everything else. So the class should be by itself. It should be able to do stuff by itself without the need to kind of talk to anybody else. So when you think about a class and think about functionality, let's say you wanted to talk to a web server and get some information. Well, that's really all the class should do. And then from then on, anybody who needs to be able to talk to a web server and get some information, they use that class. And so that's kind of the key, is you kind of have a bunch of building blocks to potentially use it later and have more functionality later and easier.
We've got Dr. Morbius in the class, in the chat room, who I like him. He's a good member of the TWiT Army, but he brings up something that, again, I think a lot of people say, which is object-oriented programming is mostly for corporate programming. He's tried OOP before, and it just makes things too complicated. I'm sure you hear that a lot from novice programmers. What would you tell them?
So I completely disagree. So sorry, Marvin. But I think one of the things you got to do is you got to understand that most people, a bunch of programs we've been showing you, they're real tiny, they're small, they're easy to follow. But if you start getting into even just if I were to program at home, I built an app for my son to show photographs on the TV. I mean, even that app has about 10,000 lines of code. And if that wasn't broken out into classes, there would be no way I would be able to fix that code if it ever broke. It would just be a one long file of 4,000 lines, and I'd have to find spots where things were breaking, and it would just be kind of a nightmare to maintain, even as a personal application. So I think it's a good practice, even as a home user, to start using classes and breaking it down into functional components, functional pieces.
Okay, enough of the ivory tower. Let's get into the IDE. Show us what it looks like when you make an abstract class. Show us what it looks like when you actually use it.
Sure. So one of the things is, if we show my screen real quick, we'll just do, again, a simple console app. And what I wanted to show is kind of getting into the abstract side. We'll also show an interface version of it too, so you can kind of see the difference. So I'm going to add a class really quick. And I'm going to call it Social Network.
Yeah, could you go ahead and bump up your font size just so that people can? There we go.
All right. So then, so this is kind of the what you see. But what we're going to add in here is we're going to add that it's public, it's visible by everybody, and that it's abstract. And it's as easy as that. So now it becomes a class. But if we go back over here, like you said, let me bump it up really good. There we go. So if I go in here to the main program that gets created when I create this app, if I try to create a social network, like you said, and I try to create a new object off of it, it's going to be like,
It's
you
not gonna
can't
know what to do.
that. Sorry, can't create an instance of an abstract class. Sorry, it's not. You're not able to do that. So we want to. So we want basically the need to this is we want to add some functionality in here, but we don't necessarily want it to have all the functionality.
Right.
So I have a little version of this here. So I'm going to copy it over real quick, and so it's faster for me to type it out. Whoops. And what it's going to do is it's going to basically be the blueprint for a social network class. So pop this in here. Whoops. And I think I'm missing a curly brace somewhere. That's why it's not formatting. There we go. A curly brace down here. There we go. So if we look in here, what is this class actually doing here? Well, first thing is it's got an email address, and this is what we call a property. And again, a property, we never really talked about them, but we consider them basically just an extension of a field or a variable. It's a way to put some code inside before you get it and before you set it. Because if I were to just put a string email address in here and make it just a field or a variable, then there would be no way for me to do anything in between when somebody was getting a value out of it or a value in between it. So this way it gives me the ability. But you notice that in here I make it virtual. So not only can I override this later, but it will just return a string whether I want to store it here or I want somebody to override it. And then also I have another property called allow number of characters, and it's allowing 140 characters by default, but I can again override this if I really wanted to. So what I want to do is also add some other implementation in here. There's some other functions and stuff that I'll add. And so we'll add to below here, and you'll see some other things that you'll notice. First thing is I added a function, which is called login, but it takes an email address. But again, it's abstract, which means it has no normally I had curly braces under here, and I have some code, but I don't have that. Because you know what? Login for every different social network, whether it be Facebook or Google+, they're all different. So most of them take an email address to start with. So that's what this method or this function has.
Right. That's a great example of where you would use an abstract, which is, look, if I'm writing a program that's supposed to be interfacing with social networks, I know there's going to be a login, but I want to give each coder who's going to code for each social network the ability to specify specifically what's going to be used. I know they'll all use the email address, but other than that, I don't. So that's what I'm going to give them.
That makes sense.
Yeah.
Right. We could even make it more abstract. I could remove email address even from here because it's like Twitter allows you to use a username too, so it doesn't necessarily take an email address. But in this case, we could just say an username like that, and that makes it even more abstract. And then we have, again, posts, very similar. It's abstract. It has no curly braces underneath it. It has no code whatsoever. And again, it takes a message. So if I want to post a message to a wall or to a public place, it just takes a message. And the very similar, a little bit more complex signature, we call this, but this says I'll take a photo too. So if I want to post a photo, it takes the bytes in an array of for that photo, and I get a message, again, abstract. Then the last one down here is actually a function, but you notice something. I actually have curly braces underneath it. And I have that it's, when I say who am I, it's going to return that the email address of the user is actually who I am. So that's kind of the key is what you'll notice is a lot of times abstract classes will contain a little bit of implementation too, because it's just a no-brainer that maybe by default there's no such functionality in Twitter to say, you know, what's my user information, and there's no way to get that. So in this case, it'll just return what my username is. So that's a way to actually add some implementation into the abstract class. So now that I have this kind of model, let me show you like a specific example of a type of social network. So like, for instance, I'm going to create a class called for Twitter. And you notice here that, actually, let me do another one in here so you can kind of see what happens when I actually do it. So I'm going to create one for Facebook. And I'm going to inherit from social network. And as you see, there was like a little blue thing underneath it. It's basically saying, well, there's some stuff you can do here. And you notice if I hover over it, it says options that you should basically implement all the abstract stuff. So all the stuff that don't have curly braces that I marked as abstract, I can click on this and say implement it. And you notice, like, immediately it implements all the methods.
That's actually, I did not know you could do that. That is fantastic. So if someone gives you an abstract class with a bunch of abstract members, the minute you type in the line to say, I'm going to be inheriting from social network, which is an abstract class, the IDE will say, oh, okay, if you're going to do that, these are all the members that are abstract. You need to actually tell me what they're going to do before I can do anything with them.
Pretty cool.
That's awesome.
Makes it a lot faster. There's a keystroke before it too for like power users, but you know, I can't remember what that is, but it basically will implement it really fast. It adds in here like, this is called an exception, but right now the reason why it does this is if you run this and then somebody tries to use it, it says, oh, by the way, this developer didn't implement this yet. So, but anyways, let me delete this because I'm not going to create a Facebook one. I'm just going to do a Twitter one for now. And I have a Twitter one, and you notice in here, they don't really do anything yet. I just deleted the exception. But again, I overrode the login, and I'm doing some other stuff in here that wouldn't normally. So I'm not going to add any implementation in here. But basically, all this would do is I'd put all my code to, post a message, and and post a photo, that kind of thing. Post a photo, and then this would call into the Twitter interface to basically do that. So now if I pop back over to my application, I can actually do something interesting. Is I can undo this, but instead, I'm going to do new Twitter. And now, I can actually do stuff. I can actually return the email address, I can log in, I can post, and now it's all because I have a specific version of that social network. And now you have inheritance, but you have a little bit of the ability to force a user to implement some things. It's a way to force a developer to implement things when you, as the developer creating that base class, don't want to implement everything. So you kind of force a user or developer to kind of implement for you.
That makes sense.
Yeah.
It's a lot easier to understand once you actually see the code.
Yeah, exactly.
So you have the layout, the abstract class, and then you have to actually make real classes from it for people to be able to use it.
Precisely. And this is why we like using this visual environment, because it gives you that option of saying, oh, I don't want to scrub through the entire class and figure out where I need to override. You just tell me what are the things I need to fill in. What we would say is, you show me what I have to fully implement. What's so cool. Not complete that I have to fill in the blanks for.
So you could use your social network one to like build an app that requires a social network login, and they could choose between Facebook, Google+, and Twitter, and then it would just implement that different class depending on which one they chose.
What you would do is you would write an abstract class with login as one of the procedures, one of the methods, and then you would put in the comments, you would say, this is where you give me all the information I need for that specific social network.
That's right.
And then it's up to the programmer who's instantiating it to fill that in.
Problem solving.
Yeah. And again, folks, we know that this, there's a lot of you who are looking at this and going, why would I do, this is silly. We're going into coding 102 here. This is what you do to enforce a hierarchy. Lou has said it, Snubs has said it, I've said it. Sometimes, especially when the program gets big, when it goes beyond you, you need to be able to enforce a certain structure to the program. Otherwise, it's going to be impossible to fix or change in the future. That's what this does, which is why we're giving it to you.
There's a really cool principle. It's kind of computer sciencey, but it's called the open and close principle, and it's the whole idea that you're always open to add things, but you should be closed to changing things. And the reason is if you build a class that has a specific functionality, you should be always open to add additional functionality. And it's easy to do that when you break it apart and have little pieces. But you shouldn't actually go back and change it because it could cause some bugs and it could break people's using that class and that kind of thing. But it makes sense because once you break things up well enough, if it's modularized well enough, it'll always be maintainable.
Okay. Lou, there is that one extra thing, the interface. This is where people just go, wait a minute, you just taught me about abstract classes. Why do I need interfaces? It seems like they do the same thing, right? And interfaces are just another way to enforce hierarchy. Why are they separate from abstract classes?
Sure. So interfaces are basically used to, like you said, enforce like a schema or what they call schema or a signature, or force you to use a bunch of properties and functions, but it forces you to implement all of them. So instead of just giving you, a couple of them, forcing you to implement them, now you have to do all of them. So like if you show my screen real quick, I give another example is where I had the abstract class, and some of them I gave you some implementation for. So one, email address, I gave you some, and then down here, the who am I actually has the returning the email address. But in some cases, if let's say I built an interface, which is just the same exact thing, you just do public interface in the name, and a lot of people like to prefix it with the I, kind of like everything that Apple does,
right.
is with a prefix with an I. Well, so most people prefix their interfaces with an I, so it's an interface. It's just an old school way of doing it.
Right.
And then you notice down here that everything it's basically like the abstract versions. It doesn't have any curly braces underneath it, and it doesn't have any code inside of it, which means now if I wanted to create a Facebook version of this using the interface, it's going to make me implement all of them. So if I do public class Facebook and I do social network, again, I get that little line underneath it, and it says, oh, do you want to implement everything? And I could say, sure, why not? Implement everything that's in here. And you notice now
it's everything.
It gives me code for every one of those members of that interface. So I have to pretty much put code in for all of them.
So whereas in an abstract class, you could have methods that are completed, right? They're non-abstract. And
That's
then
right.
just have a few abstract members that need to be customized for a particular application.
That's
when
right.
you're dealing with an interface, there's nothing there. It's all it is the signature. That's it.
Interesting.
Done.
Yeah. Right, and a lot of people, it's kind of a religious war when it comes to when you're supposed to be using interfaces versus abstract classes. And so we're not going to even try to give you, there's some best practices around it. But again, it's better to just try to play with them and see how the differences are. And then sometimes you'll figure out, okay, well, in some instances, I know the functionality, what it should be in the base, so I'm going to put it in there. But most of everything else I don't know, so I'm going to make the developer implement it. And in that case, it's abstract. And an interface, I don't know anything. Yeah. Like I just want to force them to do specific things, like log in, like return my email address. In that case, you can use an interface, and you don't have any code. You're not forced to write any base code, and that's kind of a rule that I normally follow. It's very simple, but it makes sense.
Yeah. Well, Lou, I think we have sufficiently puzzled people for this episode. So how about this? How about for homework? If we tell people to, if you're a beginner and if you are truly lost, then what we'd like you to do is take what you've just learned about classes and take some of the code from the first module, which again is available on our GitHub, and put it into a class. See what happens when you put it into a class inside of the Visual Studio IDE, just so you can get comfortable with using a class, with declaring a class, with calling a class. Do that. If you're feeling lucky, or if you are more experienced, go ahead and play with abstract classes. Take some of that same code, drop it into an abstract class, but also add abstract members. This is an incremental learning step, folks. You may not get it immediately, but as Snub said, sometimes when you see it, and when you see the IDE actually telling you what you can do, it kind of clicks.
That's right.
Hopefully.
Yeah. And Lou, all your code is going to be available on our GitHub, yes?
Yes, definitely.
Fantastic. What do we want the folks to look forward to next week? How are we going to puzzle them then?
So we're going to build upon the idea of classes, but we're going to start using what we call new collections, ways of doing. So in the past, we've learned about arrays. I think in other languages, you learned about lists and array lists and stuff like that. So we're going to build upon that inside of C# because we want you to understand that there are other objects or types that allow you to build lists and allow you to loop through them easier, and build upon your class to have more functionality. So we're definitely going to go through that. Another thing too I want to go through is there's something called there's a package system in Visual Studio that allows you to download binaries really easy. It's called NuGet. And so I want to go over what that is and basically allow you to use that to make it easier to kind of bring in third-party functionality into your app a lot easier. And that'll make it that'll build up what we're going to do next after that. So we'll go over that next week.
The first time I
love
used
nuggets.
NuGet, I was like, is this legal? I should be able to do this, right?
I'm stealing people's code.
Exactly. Like, I don't think they wanted me to be able to see what they programmed.
Yeah.
Lou Maresca, we want to thank you again for being our code warrior. Thank you for walking us through some difficult stuff.
Yes, thank you.
It's easy to code sometimes, but the concepts, remember, the concepts are the parts
right.
that we really need you to learn. And these are universal concepts. This is not just in C#. Can you tell the folks at home where they can find you, where they can find your work?
You bet. It's LouMM on Twitter. And of course, as always, crm.dynamics.com is where all my work is posted as we ship it.
Fantastic.
Thank you, Lou.
Thank you, Lou. We'll see
Thanks,
you next
guys.
week. And well done, Code Warrior. Now, folks, we realize that this was, again, a lot of material. And we know that you're going to have
ready for
fill-in
it.
material. That's fine. That's okay. But you can always find out more about what we've done each week by going to our show pages. And Shannon, where can they find that?
twit.tv/code.
Code, Twit coding, Twit code, yeah.
Yep.
And as long as you're there, you'll also be able to get the link to our GitHub. Our GitHub is where we're going to have all the code from this episode. We didn't have any code from last episode because honestly, there was no code. But this week, we're going to include the examples. We're going to include Lou's code, and we're also going to link you back to the GitHub repository for Module 1. So if you want to see some simple C# code, stuff that you can just drop in your console and make work before you start getting busy with classes, go ahead and drop over twit.tv/code.
Also, we are on iTunes and YouTube.
Woohoo!
YouTube.com/twitcoding101, and you can search for us on iTunes. Definitely check it out. Please subscribe. It helps us out, and it helps you guys get more shows. So
Yay.
we really appreciate it.
Yeah, we like more shows.
It.
Yeah. You're also going to be able to find us in the socials.
The socials.
The socials, yes. The biggest social that we use, of course, is G+. If you drop into Google+ and just do a quick search for Coding 101. Actually, did we set up a...
bit.ly/twitcoding101.
That's right, you set up a shortener. One more time.
bit.ly/twitcoding101.
Go there and join, because it's not just beginners, it's not just experts, it's not just people who tinkle around with this or do it professionally, it's all sorts. That's what's great about the community. If you have a question, ask it. If you see a question you can answer, go ahead and answer it. It's part of the development of talent, of homegrown talent for coders around the world. This is what it means to be a code monkey
I love our
/ code
community.
warrior.
You guys are awesome.
Yeah. Now, we're not just on the G+, right?
Nah, I think we're on the Twitters too.
Twitters, yeah.
Yeah.
We
I'm
keep
at
defaulting to the
Snubs,
southern thing.
Right down there.
Snubs, at Snubs. And you can find me at PadreSJ. That's twitter.com/PadreSJ. Go ahead and follow us, and you'll find out what we're doing each week on every new episode of Coding 101. Plus, you'll find out what we do when we're not doing this show. I'm all over the Twit network. Snubs is on Techzilla. She's on Hack5. You're going to find her everywhere. So follow us on Twitters and see what we do when we're not being code monkeys.
We're always code monkeys.
Yeah, we're always code monkeys.
And definitely check out our live stream. You can watch the show live on Thursdays at 1:30 Pacific time. And that's over at, what's our website? live.twit.tv.
Live.twit.tv. Find us every Thursday, 1:30 Pacific time. And don't forget, as long as you're watching us live, drop into our chat room at irc.twit.tv. We do take questions from the chat room all the way through the show, and it's a way for us to keep our finger on the pulse of, are people getting lost? Do they want us to move on? If you want to be part of the lesson, make sure you drop in and be part of the experiment that is Twit TV. I think that's it.
I think so.
Well, until next time, I'm Father Robert Baldassare.
I'm Shannon Morse.
End of line.